In the previous movie in this playlist, I showed you how to calculate the steady state or expected result of a system that has been modeled using a Markov chain transition matrix. You can do the calculations by hand if your company or institution doesn't let you use Visual Basic for Applications, which is the Excel programming language, but it's easier if you can write the script that you need. And in this movie, I will show you how to write a VBA macro that will calculate the result in a minimum of space. The sample file I'm using is Markov Movie 05, and you can find a link to it in the video description below. I'm looking at a bike share company or a bike rental company, and it has 8 nodes or 8 places where you can pick up and drop off a bike. 1 through 5, which are labeled here in blue, are in residential areas where people live. And the idea is that during this commute, which will be in the morning, from 5 in the morning until 10, most of the riders will end up in the business district where they work. And those nodes, 6, 7, and 8, are represented below in gray. And you can see the transition matrix has the probability of a bike going from a particular station and ending up at another. So in the morning, from station 1, which is here, 5% of the rides will stay at station 1, so the rider will pick up and drop off the bike at the same place, go from S1 to S2 3% of the time, S1 to S3 5%, and then you see that very few go to other residential areas here. And then, for the downtown trips, the closest to S1 is S6, so 36% go to there, another 35% go to S7, and 12% go to S8. And the other probabilities are distributed in the same way. So there are 2 things we want to do. The first is to determine the percentage of bikes that end up at each station at the end of the day, or at the end of this period, and also the number of bikes. So I have added in cell I13 the number of bicycles that are part of this network, and I've set it to 500. So the question is, how do we do the multiplication that we need? In other words, we need to multiply this matrix by itself a large number of times to get the result for the projected end state, which will go down here. And we can do that by creating a function in VBA. So I'll move over to the Visual Basic Editor by pressing Alt F11, and then I will insert a module, and I'll drag the code window up. Now in the code module, I can define my function, so I'll type function, and I'll call it steady state. And I will name the variable that we're passing in, vmatrix, as variant. And that's the only one we need. Because we're doing our multiplications inside of Visual Basic, then we'll be able to use just the one value. So I will close the parentheses, press enter, and I get the end function statement at the bottom. And one thing I will note is that I'm moving through the VBA elements pretty quickly. And the reason is because I have an Excel VBA course on LinkedIn Learning, and I have to keep everything on YouTube separate, and also I can't compete with what I put on LinkedIn Learning. So if I go a little bit quickly on some things, it's because I've already covered it elsewhere. And I will give you a link to my Excel VBA course in the video description as well. So here I need to declare 2 more variables. I already have vmatrix as variant, so I'll do dim, which is the declaration statement, I as integer. That will be a counter, and then dim vresult as variant. And I'll use this to hold a second copy of the matrix that we read in. Now I can create a for next loop that will multiply the matrix we bring in by itself 30 times. So that'll be for I equals 1 to 30. And then I'll go down below and type next, and then an apostrophe or a single quote followed by an I. And the reason I'm doing that is so that I know which variable this next is connected to. Excel VBA lets you create for next loops where the next doesn't indicate which loop it's part of. And in this case, it wouldn't be confusing. However, if you have multiple loops, especially if one is nested or placed inside another, then it can be hard to remember, at least quickly, which loop is associated with what. So I always put the variable name as a comment next to the next statement. And I just need to multiply the matrix by itself. So, actually, before I do that, I need to say vResult equals vMatrix. So now I have the second copy of the matrix ready to go. So then I will multiply the matrix by itself multiple times. So I have vResult equals, and then we'll do matrix multiplication. And for that, we can use the built-in worksheet function. So that'll be application.worksheetfunction.mmult, which is matrix multiplication. And then I need to identify the two matrices we're going to use. So that will be vMatrix as argument 1, then a comma, and vResult. There we go. And then after that has been done 30 times, we should get a steady state, and then I can return the variable to the function. So I'll do steady state. I need to type in the name of the function I gave it above, equals vResult. Okay, everything looks good. So I will press Alt F11 to move back. And then I've already selected cell C16. If you haven't, go ahead and do that. And I will type in a formula using the new steady state function that I created. So equal, then steady state. And you can see a list of functions that are available. And one reason that I use camel case, that is uppercase and lowercase letters, is to distinguish functions I create from the ones that are built in. It just helps me remember. So steady state, and we're only passing one range, so that's C4 to J11, which I selected above, then right parentheses and enter, and we get the result. So at the end of this particular segment or time period, 4% of the bikes will end up at station 1, 3% at station 2, 3% at station 3, and then looking at downtown, station 6 will have 18%, 7 will have 34, and station 8 will have 19. Now I can multiply those percentages by the total number of bikes to find out how many bikes are at each place. So actually, I will select cells C24 to J24, then type equal, and then I13, which is the number of bikes, and I'll press F4 to make that an absolute reference so it doesn't change. Then asterisk to multiply, and I can use the value just above the cell that I'm in. So that'll be C23, and because I want that reference to change, I will leave it as a relative reference. Because I have multiple cells selected, I can press Control-Enter and enter the calculation in each of the cells. So this will be the number of bikes that end up as each of the stations. And the reason that I have 18.57, where I would expect with 0.04 to see 20, is because this value is rounded. So if I select cells in the result, that's C16 over to J23, and increase the number of decimal places that are displayed, and I do that on the Home tab of the ribbon in the number group, click Increase Decimal, and you can see that in fact I have 0.37, 0.372, continuing on from there. And of course you can round your values if you want. However, in this case, this gives us a very good idea of how many bikes are going to end up at each station at the end of this particular time period. One final thing, if you want to save your workbook as a macro-enabled workbook so that you can hold on to the function, you need to press F12 to save as, and then wherever you want to save it. I have mine on my desktop in an exercise files folder. Instead of type Excel workbook, click that, and then change it to Excel macro enabled workbook. So that's there. Click save. And now you can close and keep the function that you created for use in this workbook. I hope that what I've shown you here for transition matrices and steady states is useful. If you enjoyed it, please like the video and subscribe to my channel.